Hey, welcome back to the Math and Physics Coach YouTube page. In this video, I'll be covering question 1 of the 2021 AP Calculus A/B test. In this problem, we're given several data points used to describe the density of a bacteria population at varying radial distances from the center of a petri dish. For part A, we're asked to estimate f prime of 2.25 using only the data given in the table and to explain what this answer means. We can think of f prime of 2.25 as the slope that this function would have at an r distance of 2.25 centimeters. Now, we don't actually have a density population data for 2.25 centimeters, but we can estimate it using the data points immediately preceding and following 2.25 centimeters. Because the problem specifies that we are only using the given table to find our answer, we can assume that the line connecting these 2 points will be linear, and then every point in between will have a constant slope. The slope for these 2 points can be found using delta y over delta x, or delta f of r over r, which we can solve to get 8. This tells us that at a radial distance of 2.25 centimeters from the center of the petri dish, the density of the bacteria population will be increasing at a rate of 8 milligrams per square centimeter per centimeter. For part B, we're given a function of the total mass of the bacteria in the petri dish in the form of an integral expression, which I'll rewrite here, and asked to approximate the value of this integral using a Wright-Riemann sum. A Riemann sum is used to estimate the value of an integral without actually solving the integral, and it is found by summing up the areas of each rectangle that is formed by f of r of one point multiplied by the delta r between it and the next point. We can't forget that we also have this constant 2 pi and this r value in here as well. But first, let me try to show visually what a Wright-Riemann sum is. A Wright-Riemann sum means that each data point will represent the right side of the rectangle, and the delta r will be between it and the preceding point. Let's get back to the formula for the Riemann sum, and now include the constant and the additional r value. We can now expand this summing function where, for the first index, we have an r value of 1 times an f of r value of 2 times the delta r value of 1 minus 0, which is the preceding r value. We'll do the same thing for the next 3 data points, then evaluate the approximation to get a value of 845.088. Moving on to part C, let me again show the Riemann sum visually, where each data point is used to form the right side of each rectangle. We can see here that each rectangle has this excess area that extends past the function. It is actually the case that when using a Wright-Riemann sum with an increasing function, or a function that maintains a positive slope, there will always be this excess area. Another way of saying this is that the approximation from the Riemann sum will be an overestimate. We can prove mathematically that this is an increasing function by showing that the derivative of the function, which is also the slope, is positive over this range. To find the derivative, we'll need to use the product rule. Now, if each of these 4 terms are positive over the specified range, then it's an increasing function. It should be clear that each term will be positive since r is always positive and increasing, and f of r is always positive and increasing. Hence, a Wright-Riemann sum will result in an overestimate. Finally, for part D, we are given another function which models the density of the bacteria in the petri dish. We're asked to determine at what radius will the average density be. The average of a function can be found by taking the integral of the function and then dividing it by the range of the function. This integral will be too difficult for us to solve analytically, so we'll use either our calculators or other online integral solvers. We'll find out that the average value will be around 9.8758, and setting our function equal to this and solving for k will result in 2.497, meaning the average value of the bacteria population density will be located at around 2.5 centimeters from the center of the petri dish. That's all for this video. Thanks for joining the Math and Physics Coach, and be sure to subscribe to see more videos or to request problems that you'd like to see me cover.